Algebra I, Day 3, solving equations with variables on both sides using the distributive property. So today we're going to be talking about solving equations that have parentheses in them on both sides, meaning there's a lot of stuff that's set up to confuse us, okay? So there's a couple of different steps that people typically follow, and a lot of times they work differently for different people, so don't think that this is the only way that you can do it, but this is kind of the suggested way. So let's go ahead and go through those steps. So first, I want to distribute on the left. Then I want to distribute on the right. We can go ahead and draw draw lines in front of every single one of the signs, so in front of every plus, every minus. Combine like terms. And get the variable, whatever that might be, x, y, z, a, b, c, on one side of the equation using addition or subtraction, and we always pick on the little guy. What does that mean? We always move whoever's smaller. So the way to remember that, because that applies to a lot of different equations and a lot of different things, is that imagine that in the room that you're in, I had asked you to move everything out of the room. I told you I'd help you. And I give you a choice. Do you want to move something really big and heavy or something really small and light? Well, of course you'd say small and light. So same thing applies to the equation. We don't want to move something really big and heavy. We want to move whatever is small, light, and easy for us to do. So that's going to be the small least value item. Step 6, we're going to use our inverse operations to isolate the variable. A super fancy way of saying we're going to do the opposite to get the variable by itself. Let's take a look at example number 1. And like I said, everybody kind of develops their own way of doing this. I really think that the steps are in any particular order something that you have to do exactly that way. But just know that there are certain things that make it easier, okay? So first thing, let's distribute over here on the left. I'm going to bring down my equal sign. I'm going to distribute on the right. Okay, so I got that. So we could go ahead and draw a line in front of every sign, but I kind of already know where everybody is. I'll just highlight the individual terms just to kind of clarify that. So I'm going to combine like terms. I look over here on the left side, these guys over here. I don't notice anybody that can be combined. I'm going to do the same thing over here. Nothing that can be combined, so I'm good with combining like terms. Now I want to go ahead and get my variable on just one side. So I need to take a look. I see that I have x's on both sides, a 4 and a 6. And remember what I said earlier. We always want to move whoever's smaller. The reason is it's easier. So let me first, before I go ahead and do that, say that I decided to move this 6x, right? So I would do minus 6x, minus 6x. And look at that. Now I've created a negative. I've made a really messy situation, right? So yes, technically, according to math, we can totally do this. We can still get the right answer. But the reason why we want to do the small one is we want to avoid creating those negatives and making things more difficult for ourselves, okay? Let's go ahead and go back a little bit. All right, so let's move that 4. Okay, so I got that. And so now I want to use my inverse operations to isolate the variable. Remember, that's just a fancy way of saying I want to do the opposite of everything in order to get my variable by itself. So first thing, I need to figure out what I'm focusing on. Obviously, it's that x. I'm trying to get it by itself. So what I'm doing is I'm going to go ahead and I'm going to get rid of everything that's on the same side with x, same side of the equal sign. Now, here's the thing. You always get rid of the thing that is on the same side as x, but that is not attached to x. Why do I say that? Because even though in this case I could divide by 2 and everything would work out to whole numbers, sometimes x might have a coefficient that's an odd number or an unusual number like 3 or 7 or something. And whenever I divide everything by it, I'm going to start making all these crazy fractions. So we want to avoid that, right? So we always do whatever's not attached to x first because we're trying to minimize the amount of fractions that we make, and then we do whatever's attached to x. Remember what I said on day 1. Exciting move, great divide. So every time I see something like this, I should think, okay, equation. Usually, very last steps are going to be exciting move, great divide. So first, I'm going to go ahead and move my 12, and I end up with 36 equals 2x. That was my exciting move. Now I'm going to go ahead and do my great divide. Divide by whoever is attached to x. And I find out that my x has a solution of 18. Okay, so let's go ahead and go on to the next example. Now, this guy has some decimals in it. So there's a couple of different ways that we can deal with this. So in my mind, whenever I see decimals, I always say, all right, are there easier fractions? Is there something I can multiply them by in order to get rid of them? There's so many different ways, right? But I'm going to walk through this really slowly so you'll understand where my mind goes when I see this. Point 3. This is what people call the 10th place, right? The reason is that this is actually 3 over 10. And I'm just going to write that out like that just so I can make a point. Okay. So yes, I could go ahead and multiply these in. I could do all kinds of fractions and crazy stuff. But remember, we want to avoid all that. We don't want to make stuff more complicated than it needs to be. So whenever I see something like this, I realize that for how many ever decimal places there are, I just multiply by that number of 10. So for example, in order to get rid of something that looks like this, I'd multiply by 10, multiply by 100, multiply by 1,000. The reason is 110, 2 tens makes 100, 3 tens makes 1,000. Now I know that might seem like some super weird math, but all we're doing is we're just getting rid of the decimal. And the reason why we want to do that is we don't want to start making all kind of weird fractions and stuff. Because, for example, this multiplied times 0.3 might make some kind of crazy fraction, right? Or some other kind of crazy decimal. I don't want to deal with all that. That's too much. So the reason why I said that is I also wanted to make sure that we looked at it this way. 0.3 is the same as 3 over 10. 0.4 is the same as 4 over 10. So I can multiply both of those guys by 10, right? And if I do it on both sides, it stays equal, and they just cancel out. And I end up with some fancy whole numbers. That makes everything a lot easier to deal with, right? No decimals, no fractions. I like to keep it simple. Okay, let's go ahead and keep going. So here, I'm going to go ahead and distribute. I'm going to do the same thing over here. Okay. So now I'm at the point where I want to make sure that I don't have x's all over the place. I don't have numbers all over the place. I want to make sure that I'm going to make my math simple, right? Because I don't want to have to keep moving stuff around. So what I do in this situation is I look only on this side and I say, all right, is there anything I need to combine? No, all my x's are together, all the regular numbers are together. So we're good over there. What about over here? Nope, all of the x's are together, all of the numbers together. Okay, so we're good on that. So what I can do now is I need to get all my x's together. I need to move one of these guys. And I look at them and I see a positive 36, negative 12. Obviously, negative 12 is going to be much smaller. So I'm going to move that guy. Okay, lots of 48s going on there, right? So let's go ahead and keep going. Here I'm at the point where I just have two more steps. How do I know that? Well, there's coefficient x, constant equals something else. Excited move, great divide, every single time. So I'm going to go ahead, I'm going to move my 48 because it is not attached to my x. And then I'm going to go ahead and divide by my coefficient, whatever is attached to my x. And I find out that my solution is x equals 2. So keep in mind, they give us all that just to get down here. All right, example 3. So here we have 3 times parentheses 5x minus 15 and another fraction on the other side. So for this one, they're not decimals, so I can't just quickly say, oh, well, how many 10s do I need to multiply by? But the good news is that they have the same exact denominator, the number at the bottom, 5. So that means if I multiply both sides by 5, I can quickly eliminate those fractions. So I'll say multiply by 5, multiply by 5. That cancels, and this is what I'm left with. Now, over here on the right side, I intentionally wrote that 1 there because I want to prove a point, remembering that we don't always have to write that. So some people may just write it like that, right? But take it a step further, I don't even need the parentheses anymore because 1 times anything is still the same thing, right? 10x times 1 is still 10x. So I don't even need the parentheses. That's automatically distributed for me. So let's go ahead and finish solving this. Let's distribute. Okay, so I got that now. Okay, so now I'm going to go ahead and get all these things together to make sure that they're all combined. Over here on the left, everybody's combined. I don't have x's all over the place, numbers all over the place. And then everything looks good over here on the right. So now I'm going to move one of these x's, 15 and 10. I'm going to move that 10. That's much smaller. Okay, so now I have 5x minus 45 equals negative 25. Again, very last step. So I can move, great divide, every single time. I'm going to move my 45. And I'm going to divide by whatever is attached to my x. And guess what? I ended up with a super simple answer. So, just to kind of keep helping you guys along, I decided to make sure that we had a couple of extra problems that I wanted to include in this video. So here would be maybe something that you might see on the STAR test, right? So it would say solve this, and they give us this long, crazy equation. So first of all, I want you to notice something. This minus 6 go together. So just to explain why, you could also write this like this, plus negative 6 parentheses 3x minus 5. So technically that's part of the 6, okay? So don't just go distributing and then leaving the negative out and forgetting about it, all right? Let's go ahead and go through this problem. So 24x is not going to change. Negative 6 times positive 3x minus 18x plus 30 equals, and we're going to distribute over here, 44x plus 11. All right, finally, we have one where we're going to combine like terms. I see that over here on the left side, we have all these x's all over the place. I don't like to deal with all that. I want to make sure that I get them all together so that way I'm not constantly moving these. So I'm going to combine them. Okay, so now I've got everything combined. Left side looks good, right side looks good. Let's go ahead and move one of these x's so I can get them all together. I'm going to move this 6 Okay. Okay, so now I got that. So now I'm going to focus in on my variable, this guy. I need to get him by itself. Exciting move. And great divide. Always in the same order. So I'm going to take away whatever is already on the same side, but it's not attached to my x, and then divide by whatever is attached to it. So I end up with this. And in case you didn't notice, that's exactly 1/2. So my answer could be written as 1/2. Some people might write it as 0.5. Some people might write it as 0.5. I'm not that picky about it, but I just wanted to make sure that everybody understood that those were equivalent. Okay, so let's keep going. Let's get one more in. Okay, so here I have another one. Negative all over the place. They're really playing with my emotions on this one. So let's go ahead and first start by just distributing. This one's not going to change. I copy it over. Not going to change. I copy it over. Here they have a negative in front. So I'm going to distribute it like it was -1 plus 9 plus 2x. Okay, let's go ahead and start combining like terms. Over here, I have the x's. Over here, I also have x's. Okay, so now that I'm done combining, I can go ahead and start getting my x's together. I'm going to move my 2x, that's the smaller of these. Okay, now I'm going to go ahead and do exciting move. Great divide. And I see that this is 24 over 36. Now, I am used to not doing things with, used to doing things without the calculator. So what I would do is just start dividing by 2 until I figured out something. 12 over 18, 6 over 9. Can't divide by 2. Let's try 3. And we got it reduced all the way. So my answer is x equals 2 over 3. All right. Thank you for paying attention to me throughout the video. Go ahead and finish up your assignment and have a good rest of your day.